Hello everyone, welcome back to MAT052. Final week, and I just wanted to go over and review some things between the difference between two proportions, doing a confidence interval and a hypothesis test, and I'll do a little review here and then we'll go over some worksheet problems and call it a week. So nothing to turn in for this week. So let's get started on our slides. So confidence intervals and hypothesis testing for a difference of two proportions. And again, we're just going to do kind of a mix of this, but I want to go over the confidence intervals for a difference for two proportions. So we can test hypotheses about the difference between two proportions. The test statistic has a standard normal distribution, which means that we're going to use the standard normal table, and it'll be a Z test statistic. Here's the formula for the test statistic. Let's go back. The assumptions that are necessary for tests involving a single proportion must hold for both populations. So what was that? We needed NP and N times P minus 1, both of these, to be greater than or equal to 10. So both ends of it, okay, that we had to have at least that many inside and to get started, okay? So we have to have that available for both. Those have to be true for both sets, because we're going to be doing, here's our population, and then we're going to have two populations here. And I'm talking about, so I've got a population proportion P1 and P2. So this population may be all males, all U.S. males, let's be specific. And this one population would be all U.S. females. And I wanted to know something about the proportion that, let's say, like Mountain Dew between the two. So that's kind of what we're going to do and see if there's actually any difference. So we could be looking at things as P1, this P1 equal to P2, or is P1 greater than P2, or P1 less than P2? So those type things. Let me kind of open this up a little bit for us. Okay. All right. So that's what we're going to be doing. Let me get my eraser here, and now we're going to go on to our slide. So here's the test statistic for the difference between two proportions. So if I'm going to do hypothesis testing, if I want to do a hypothesis test based on some of this, I'm going to use a Z-type test statistic. P1 hat, so what are we going to do to determine this is we're going to go over here and get a sample and go over here and get another sample out of that one. Okay, the sample 1's going to have a proportion P1 hat. The sample proportion 2 is going to have a sample proportion P2 hat. Okay. Now this has P1 minus P2 hat. So the sample proportion 1, the sample from population 2, sample proportion from population 2. And when we do the standard error type from here, I'm going to use the pooled version here. I'm just going to have a P hat, 1 minus P hat, 1 over N1, plus 1 over N2. All of that is under that square root. But here we're defining our P hat to be X1 plus X2 over N1 plus N2. N1 is the size of the sample from the sample 1 from population 1, and N2 is the size of the sample from population 2. And that's called the pooled proportion. So this is called the pooled proportion. Okay. So here is a hypothesis testing example. Two suppliers of machine parts delivered large shipments. A simple random sample of 150 parts was chosen from each shipment. For supplier A, 12 of the 150 parts were defective. For supplier B, 28 of the 150 parts were defective. The question of interest is whether the proportion of defective parts is greater for supplier B than for supplier A. Let P1 be the population proportion of defective parts for supplier A, P2 the population proportion of defective parts for supplier B. State an appropriate null and alternate hypothesis. Okay, so I'm going to keep those available for a second, and I'm going to leave that right down in the corner because we'll need that. Let's erase this piece. So here we have got, maybe I got to pull this down. We get a little piece of it here. So here we've got the sample, so this is P1, but it's sample 1, okay, from P1. And we've got 12, so X of 1 is 12. N1, the size of the first one was 150, okay. And then from the P2, this is my sample 2, I got out of population 2, I had X2 was 28 over, and this is again 150. So our proportion P1 hat is the 12 over 150. P2 hat is the 28 over 150. Both of these are bigger than 10, so we're good. It meets our criteria. And now let's start setting up our hypothesis test for that. So over here it's saying let P1 be the population proportion of defective parts for supplier A and P2 for B. And it wants to say that the question of interest whether the proportion of defective parts is greater for supplier B, that's P2, than for supplier A, the P1. So P2 greater, and I want to do the one on the left side, just like we read left to right. This is our claim or our question of concern. Okay, so I need two versions of this. I've got P1 less than or equal to P2. This is the complement. Here's the claim, the complement. Once I've got that set up, then then and only then do I need to assign H0 and H1. H0 goes with the equal sign always, don't worry about the claim. This just gets you started. I have to have a claim that I get a complement. Then I assign H0 and H1, the H0 being the one that has the equality. Okay. So H1 tells us the test. Which hypothesis test? Points to the left, so that's going to be a left-tailed test. So here, that's our left-tailed test. Okay, so let's just do the test statistic, and then we'll talk about that piece of it later, because we're going to need to know at some alpha version. And let's just go ahead and say 0.05. We're going to test this at the 0.05 level. Here's our fail to reject region, and here's our rejection region. Okay. So our test statistic, here's our P1, P2, our pooled version. That's our pooled version X1 plus X2. There's our X1 and X2. Over 150 plus 150, and that is going to be 12 plus 28 divided by 300. And this is 0.1333. Let's go to 4 decimals. One minus P, I'm sorry, so this is just P hat There's P1 hat. This is P1 hat. There's our P, that pooled version. 1 minus P hat is the 1 minus 0.1333. And then that's 0.8667. And with that, we can calculate the test statistic. And that's the, let me go ahead and write these as decimal numbers here, the P1 hat. .08. This is 0.1867, and then we've got everything. So 0.08, put it in parentheses because I want to do this first before I do any dividing. Plus 0.1867, and then our square root of 0.1333. 1 minus 0.133, so that's just 0.8667 to save me some space. 1 over 130 plus 1 over 150, and 1 over 150. 2 over 150. Okay, so this was 1 over N1, our 150, and there was our 150. So this value, I type all this into my calculator. Just start over. 0.08 plus 0.1867 divided by second square root 1333 times 0.8667 times 2 divided by 150. And I get a 6.7952 as our test statistic. Oh, that should have been a minus. Minus 2.7186. That looks more reasonable. Okay, so the only thing I need to do here is find the critical value for alpha equal to 0.05. To do this by regions. So I'm going to go to my A.2. Or just let me go ahead and use my calculator. Second distributions, inverse normal, and this should be a negative 1.645. So there's that piece of it. Here's the critical region. So that's basically for here. This is out there. If I plot this, this is minus 2.7186. Further to the left in the rejection region. So this says that we should reject H0. And if there's sufficient evidence to reject H0, then basically we can support the alternate. So over here, when I pull this down, this one gets crossed out. This is the only one. So there's sufficient evidence. That happens to be the claim. So there's sufficient evidence at alpha 0.05 to support the claim. That P1 is less than P2, the proportions. Okay. So if I do a confidence interval, this is going to look very similar. I've got a Z alpha over 2. If I'm going to do Z for hypothesis testing, I'm certainly going to do it the Z's with confidence intervals. So there's my critical value Z alpha over 2. Here's the standard error. P1, 1 minus P1 hat, plus P2 hat, 1 minus P2 hat. So these, we're not going to use the pooled for this. It's just going to be the individual ones. And that's going to give us the confidence interval for the difference between the two population proportions. So let's work through a confidence interval version. And I'm going to go back up here and I'm going to write this down. So our margin of error is going to be the Z alpha over 2 times the square root P1 hat 1 minus P1 hat over N1 plus P2 hat 1 minus P2 hat over N2. Okay. Let me clean this up a little bit. Let me clean this up. 1 minus P2 hat, close parentheses. Okay, so now that we've got that, let's go through and build one of these. So the polling results, a simple random sample of 400 voters in the town of East Overshoe was polled, and 242 said they plan to vote in favor of a bond issue to raise money for elementary schools. A simple random sample of 300 voters in West Overshoe was polled, and 161 said they were in favor. Constructed 98% confidence interval for the difference between the proportion of voters in the two towns who favored the bond issue. So here, no claims confident. We're just going to build a 98% confidence interval for the difference between the two proportions, just like that. Okay. So our P1 is always, we want this to be the first one that's being described. So here's our P1, here's our sample based on our P1, and this was, X was 242 out of our numbers, X1, N1 of 400, 242 out of the 400. And then our P2, which is our sample 2, from P2 gives us our sample 2, 161 out of the 300 voters polled there. So our P1 hat is going to be, hold on, 242 over 400, 0.605. Our P2 hat, 161 out of 300. 61 out of 300. And this was our 242 out of 400. And this was 0.5367. So we can build, this is the standard error part of it. And what we've got is the critical value. So here, let me pull this down a little bit. Here's our critical value times this is the standard error for the difference of two proportions. Okay. So our standard error looks like square root of 0.605, 1 minus 0.605, divided by our N1, which is 400, plus P2 hat 0.5367, 1 minus 0.5367, all over our N2 of 300. So the standard error, let me do that as a calculation real quick. Second square root, 0.605 times 1 minus 0.605 divided by 400 plus 0.5367, 1 minus 0.5367, and that was divided by our 300. Close my parentheses, and if I get this right, this should be 0.0378 to 4 decimals. Okay, so I need to take that and do the critical values, so my Z alpha over 2 next. This is the standard error. Z alpha over 2. So I need this. We go over, let me kind of go up here. Need to build this. There's our two-tail version with 98%, 0.98, 0.02. 1 minus 0.98 is 0.02. That's my alpha. And here's alpha over 2. Since I got two tails, I have to split it. And this would be 0.01 and 0.01. So I'm going to use my calculator distribution tables again to do the inverse normal. And this time I'm going to do 0.01 as the area. 0.01. And that gives me a critical value. This based on, so let me write this down. This is 0.01 is 2.326 if we go with 4 decimal places. You really should carry all of these out to all the decimal places you can and then get your final result rounded. Okay, so let me bring this down a little bit. And then my margin of error is equal to my standard error times my Z alpha over 2, 2.3263 times 0.0378. And that is 2.3263 times 0.0378. 0.0879. So what we're going to do is that we have to do our P1 minus our P2. So P1 minus P2 hat, and that is our point estimate. And the difference here would be 0.605 minus 0.5367 0.0683. So I'm going to write this as 0.0683 minus 0.0879 less than P1 minus P2, that's the population difference, and then 0.0683 plus 0.079. 0.0683 so negative 0.01. Let me kind of open this up a little bit more for us. And here's our final calculation. Negative 0.0196 less than P1 minus P2. And then that is less than 0.15623. And that would be our confidence interval based on this polling results. So we can say with 98% confidence, and we have to kind of finish this up, we can say with 98% confidence that the true population proportion differences lies between negative 0.0196 and 0.15623, with this possibility being that there's no, since 0 is between here, that there is no difference between these two polling results. Okay, so that basically covers the slides. Again, kind of go over these, and hopefully they'll help you out, and good luck on your test.